Hey, Lanham here. We're going to talk about the outer planets of our solar system right now. But I gotta point out this interesting picture here. It's if you ever Google solar system, look it up, you'll see this. It's interesting because the sizes are somewhat close, but the distances are insane. Um, if I heard an astronomer say, Mike Brown said that if you were to make a placemat of the solar system, and this would typically be the way it looks, it'd be really boring because it'd be a bunch of little dots that you could barely see spread across the mat. So, interesting. Okay, so outer planets, what's different about them mainly is one of the big things, okay, no pun intended, is their size. They're huge, they're ginormous. They're made of totally different materials and they have lots and lots of moons. Mercury and Venus don't have a moon. Earth has a moon because of a collision. Mars has two moons that look like potatoes. No joke. They're captured asteroids. In fact, I think one of them orbits backwards. But these moons seem to be a natural sort of thing. They have rings. All four of them have rings. So Jupiter, Saturn, Uranus, and Neptune. Hold on, I had to think about it. They all have rings. So, very interesting. Okay. In order to understand not what's so different, but why the outer planets are so different, you have to go back to the solar nebula. This is where things would condense, and the rocks and the metals could condense close to the sun, but it was too hot for ices and gas to accumulate close to the sun. They went further out away from the sun, and that's why we've got all our gases and ice, and I mean water ice too, okay? So mainly hydrogen and helium, but these planets are huge, but because of what they're made of, they tend to be very low density. They say that Saturn's density is less than water on Earth, so if you have a little fun with your thinking process here, use some imagination, Saturn could float in a bathtub. Be a big bathtub. Okay, so let's specifically talk about Jupiter. I'm at a loss for words here. It's big. The 99% of the mass of the entire solar system is found in the sun. That 1% is all the planets and asteroids and comets and dust. And 3/4 of that is just Jupiter. It's massive. What do we do with all that mass? We have lots and lots of gravity, which causes a huge crush toward the center. The center of Jupiter is squeezed so tightly, it's just really, really hot. Okay. If we cut out a little, section of it, we'll notice that there's a very, very thin layer of hydrogen at the top. And this is what you think of as hydrogen. It's a gas. You're probably thinking flammable, but there's not enough oxygen there. I mean, it wouldn't do anything. But as you get further down, it was hypothesized a long time ago that the hydrogen would be squeezed so tightly it would start to act as a liquid and would actually behave as a metal. It wasn't until about 20 years ago that they got that replicated. They actually did it in a lab. They squeezed hydrogen at such insane pressure that all of a sudden it started behaving like a liquid and a metal. It generated a magnetic field. That's actually where Jupiter's magnetic field comes from. So most of Jupiter is this bizarre state. And if you think of the periodic table, hydrogen is a gas, a non-metal, and it's way over on the left with all the metals. It's got one valence electron, it's in group 1. So under these circumstances, it behaves perfectly like a metal, like one of the alkali metals. The first group is alkali metals. The core heavy elements, meaning silicon and oxygen and so on, it's basically a bunch of rock. It's about 10 to 20 times the mass of Earth, and this is just the core. Some astronomers say that Jupiter is like a giant vacuum cleaner. Its gravity is so immense, it grabs things and pulls them in, so this would be a lot of leftover particles and comets and asteroids. So things that might have caused serious problems on Earth probably went to Jupiter. We probably would not have life on Earth if it weren't for having a large planet like Jupiter. How about that one? This liquid metallic hydrogen creates its magnetic field. Its magnetic field is so strong that when particles, ions, charged particles, get caught up in it, they accelerate. That's what charged particles do in a magnetic field. They accelerate so much that it becomes dangerous radiation. When we send our spacecraft to Jupiter, we will do these big, long orbits, elliptical orbits, so that they go far away from the satellite, will go far away from Jupiter, and then zoom in really fast through the radiation and back out again, so it spends less time in the radiation. So we have to basically build our satellites for this very dangerous environment. Like we said, the atmosphere is mostly hydrogen. Very, very shallow cloud layer. I mean, it's like deeper than Earth, but, compared to the whole planet, it's pretty shallow. So if you were to jump in, the pressure would slowly build, and you'd reach a point where, forget the oxygen and all that, but you'd die just from the pressure. And the pressure would eventually be so great, the hydrogen would just gradually turn into a liquid. You wouldn't splash into it. It would just be like, oh, when did this turn into a liquid? There's the great red spot of Jupiter. It's persisted for centuries. We know that because Galileo discovered it. In fact, in the 90s, we sent the Galileo spacecraft to Jupiter.
Galileo spacecraft launched in 1989 aboard Space Shuttle Atlantis.
And the flight director has just confirmed the successful deploy of Galileo.
The significance of Galileo's study of Jupiter lies in the fact that Jupiter holds clues to help scientists understand how the sun and planets formed over 4.5 billion years ago. Galileo was the first mission to measure Jupiter's atmosphere with a probe, and the first to conduct long-term observations of the planet and its moons. This has been a NASA history moment, celebrating 45 years of discovery and exploration.
It's been a little longer than that now, but they actually dropped a probe into Jupiter and measured it directly. So that probe is now part of the core. I don't know if it's sunk down that far yet, but in 1979, Voyager 1 was one of the spacecraft we sent out into deep space, and we used the planets as slingshot effects. We took some pictures, and the center of the image right here is actually blacked out. There's a little disk covering Jupiter, so when you like putting your hand over the sun, and so you can see things up in the sky, and it found rings. Jupiter has rings. They're very, very faint, very hard to see, but they are detectable. Okay, this one's cool. In the 90s, there's a husband and wife team and another guy, and I cannot remember which one's what, Shoemaker or Levy, but they have found a lot of comets together. This is the 9th one they found, and they found it orbiting Jupiter, and they realized after calculations that it was going to crash into Jupiter, and we had never ever seen anything like that before. So As the comet, which is like a fragile snowball, got closer to Jupiter, Jupiter's gravity broke it up into pieces. So it was like a train of comet pieces. And when it hit Jupiter, you can see these infrared blobs here at the southern part of Jupiter. Those explosions are way bigger than planet Earth. If that comet had hit Earth, that would have been like worse than the extinction when the dinosaurs were gone. I mean, it would have been. I don't think anything besides bacteria would have survived that one. If that, it might have just molten the surface of Earth. But there's one picture from Hubble where there's an explosion out, where it hit on the other side of the planet, but the explosion is seen over the horizon, and I mean that just would have been a planet annihilating comet sort of thing. So it does happen. We've seen it here and there. Okay, Jupiter's moons. These are called the Galilean satellites because Galileo discovered them. If you go out with your digital camera and zoom in, or a cheap pair of binoculars, you can see them for yourself. They look like little tiny diamonds on either side of the planet, and they will change position over a few hours and days. So you really should check those out because, dang. First one is called Europa, and I want to point out that surface, these cracks and everything, and the brown stuff. Yeah, that's cool. It's a little smaller than Earth's moon. It's very, very dense, so that's definitely rock and metal. However, what Voyager noticed, and then Galileo in the 90s noticed, is that there's no craters. The surface quickly erases them, and those cracks in the surface change, and the analysis of the light coming from the surface shows us that it's water ice on the surface. There is one place on Earth where water ice has cracks that are constantly changing, and that's at the Arctic Ocean, the ice over the North Pole. There's a hidden ocean. On Earth, the deepest part of our ocean is about 6 miles deep. We think this ocean is about 100 miles deep. So there is liquid water, which is necessary for life on Earth, and there's enough heat. It's actually from the gravity of Jupiter kind of bending and warping the planet a little bit, and that friction causes the heat. Not planet, moon. But yeah, this is like one of the best opportunities, we think, for finding life in our solar system. And the European Space Agency plans to send something to go check it out. We'll probably have to look at the surface. The ice is 2 miles thick, okay, at least. So, plus, we don't want to really send a spacecraft there and accidentally introduce Earth bacteria or viruses. We do know that things like the flu virus has survived years in space on spacecraft. And there's a multicellular organism called a tardigrade or water bear that is found all over Earth and like even up in the atmosphere. And those have been known to hitch rides on satellites and survive the cold and radiation and vacuum of space for years, come back to Earth and pop back to life. So we don't want to contaminate something. So it's going to have to be a very, very careful mission. Io is the first thing besides Earth where we found active volcanoes. So yeah, check out that is a real color image. If you were looking out a window, that's what you would see. And when I see that and think volcanoes, it makes me think of like Yellowstone and that sulfur smell. You're not going to get there and smell it because there's no atmosphere, but yeah, totally. Callisto is very heavily cratered, dark. It is a very old surface. Nothing's much changed. When I first made this, I put probably contains liquid water deep below the surface. Kind of cool. We think there's an ocean below the surface, about 100 miles below, about the same volume as the Atlantic Ocean. We've actually, from measurements, think that it's liquid and that it's salty. And yeah, that's probably another great place to find life. Bacterial. Ganymede, check out the surface. This thing has been like, we believe that it was completely shattered, and then gravity put the pieces back together like a random puzzle sort of thing. So Ganymede's kind of a weird little moon there. But Jupiter, up until I think last year, had the record for number of moons at something like 60 moons. And they've found more moons. They did a different method of finding moons and found even more moons around Saturn. I believe we're at like 80 something moons now. So Jupiter's really cool. It's a beautiful planet just seeing it in the night sky. So check it out. Saturn is next. Where is Saturn? Saturn, there we go. Okay, Saturn has got to be one of my favorite planets. I mean, it's cool to look at. There's a lot of stuff. I don't know what my favorite planet is, to be honest with you. What you're looking at is not an artist rendition. It's a photograph. I'm going to show you something cool. The Saturn is named after the Roman god of agriculture, which is where we get our term Saturday from. When Galileo looked at it, he initially thought that there were little ears around it. He did not know what it was. We had a very poor telescope, that there was, maybe it was sitting on a plate or something like that. 50 years later, this Dutch guy by the name of Huygens, realized that they were actually rings. We got better telescopes. And a little bit later, this guy by the name of Cassini noticed gaps in the rings. So we actually will name those gaps after him. In the 80s, we sent the Voyager spacecraft looping around Saturn and Pioneer. So we got some pictures. And then, named after those other two scientists in 97, check out this satellite. Those are people right there below the satellite. So it's a big satellite. Cassini-Huygens went around Saturn and did a lot of stuff, and Huygens was a probe that had dropped into the atmosphere. Now, I'm using Prezi, so it's old and doesn't like to edit very well, so I can't really edit out the question mark, but Cassini was officially done a few years ago, so 2015, 18, something like that. I believe they crashed the Cassini spacecraft into Saturn itself, and like I mentioned with Jupiter and bacteria, that was so we didn't contaminate one of the moons. Oh, I forgot to mention that about Galileo. They were originally going to send Galileo spacecraft into a erupting volcano on Io to make measurements, and then they realized there's too much possibility of life on these other moons of Jupiter, so they crashed it into Jupiter instead, so they didn't contaminate anything. Crazy. Okay, Jupiter is interesting. It's, did I say Jupiter? Saturn is interesting. It's about a third the mass of Jupiter. It doesn't have a large core like Jupiter does. It's got a smaller magnetic field. It's still got the liquid metallic hydrogen, but just not as much, and it's got some pretty darn strong winds. Its rings, of course, are the most exciting because that was the first planet we saw with rings. Galileo noticed them, just didn't know what they were. They're actually made of ice particles. They can be anywhere from a grain of sand to a house. And what's interesting is that even though the rings completely dwarf the size of Earth, they're razor thin. They're hundreds of thousands of miles from edge to edge, and yet they're less than 100 feet thick. So it's really cool. The gravitational effects are what keep them in place, and it is water ice too. Okay, Saturn's got some cool moons. One of them is Titan. I think this is the one that's bigger than the planet Mercury, and it's a moon. It's got a very, very thick atmosphere of methane. Methane is the natural gas that you get from your stove, cow farts, bacteria farts, people farts. But it's so cold, it's a liquid. You actually have the same process as you have on Earth with water, except this is methane. There are lakes and rivers and oceans, and you can see terrain where rivers flow, but it's all methane. Yeah, that's the one bigger than Mercury. The Huygens probe, Huygens was landed on Titan, not into Jupiter like Galileo. I was getting those mixed up. It landed on the surface and snapped some pictures, but it didn't last long. Those rocks are water ice, and they are so cold they're going to be as hard as granite. So when I first heard this, I was like, oh my gosh, bear with me, totally geeking out here. But if there were aliens, there have to be aliens for this to be observed. I want to go down there, greet the aliens, pick up a rock and melt it and drink it, because to them I would be drinking lava. It's just water. But seriously, that would be great. Okay, some of these moons. There's Phoebe, which orbits backwards. Captured asteroid. There's Tethys, icy. Water ice. There's Enceladus. It's got water ice. Those geysers, that's water ice. And Cassini flew through one of those geysers and made measurements. It's salt water. They believe there's also a deep ocean just like Earth's under the deep down in it. Liquid, salty. Yeah, more chances of life here. And here's Mimas, and if it looks familiar, it was discovered after Star Wars was made. So this is one of those where nature imitating art. Kind of cool there. Alright, I told you that this is a photograph. It is not an artist rendition. The sun is behind Saturn in this picture. And right over there is planet Earth. That's what it looks like from way back there. And I'm going to have to redo that one. Thanks.